Download this code from codegive.com, link in the description below. Area under the curve, a comprehensive guide for jeemains. Area under the curve is a crucial topic for the jeemains exam. It tests your understanding of integration, curves, and geometric interpretation of definite integrals. This guide will delve into the concepts, problem-solving strategies, and common pitfalls related to this topic, along with code examples using Python and SymPy to visualize and verify your solutions. Foundational concepts. 1. Definite integral as area asterisk. The definite integral indefinite integral sub a slash sub b slash sub f, x, dx represents the signed area between the curve y equals f, x, the x-axis, and the vertical lines x equals a and x equals b. Asterisk signed area, if f, x, 0 on a, b, the integral gives the area above the x-axis. If f, x, 0 on a, b, the integral gives the negative of the area below the x-axis. 2. Area below the x-axis asterisk. If the curve lies below the x-axis on the interval a, b, the area is given by indefinite integral sub a slash sub b slash sub f, x, dx equals dash indefinite integral sub a slash sub b slash sub f, x, dx. This ensures the area is a positive value. 3. Area between two curves asterisk. If f, x, greater than or equal to g, x, for all x in a, b, the area between the curves y equals f, x, and y equals g, x, from x equals a to x equals b is given by indefinite integral sub a slash sub b slash sub f, x, g, x, dx. If f, x, and g, x, intersect within the interval a, b, you need to divide the integral into subintervals where f, x, greater than or equal to g, x, or g, x, greater than or equal to f, x, and take the sum of the absolute values of the integrals over those subintervals. 4. Changing variables, integration with respect to y. If the problem is easier to solve by integrating with respect to y, rewrite the curves as x equals f, y, and x equals g, y, where a less than or equal to y less than or equal to b. The area between the curves is then given by indefinite integral sub a slash sub b slash sub f, y, g, y, dy. Again, f, y, and g, y, are the functions expressing x in terms of y. 5. Symmetry asterisk. Exploit symmetry to simplify the integration. If the region is symmetric about the x-axis, y-axis, or origin, calculate the area of one portion and multiply by the appropriate factor. For example, if f, x, is an even function, f, x, equals f, x, then indefinite integral sub a slash sub a slash sub f, x, dx equals 2 indefinite integral sub 0 slash sub a slash sub f, x, dx. 6. Important curves asterisk. Be familiar with the equations and shapes of common curves like straight lines, y equals mx plus c. Parabolas, y equals x sub 2 slash sub plus bx plus c, x equals I sub 2 slash sub plus by plus c. Circles, x sub 2 slash sub plus y sub 2 slash sub equals r sub 2 slash sub, xh, sub 2 slash sub plus, yk, sub 2 slash sub equals r sub 2 slash sub. Ellipses, x sub 2 slash a sub 2 slash sub plus y sub 2 slash b sub 2 sub equals 1. Hyperbolas, x sub 2 slash a sub 2 sub, y sub 2 slash sub slash b sub 2 slash sub equals 1, x y equals c sub 2 slash sub. Asterisk trigonometric functions, sin x, cos x, tan x. Asterisk exponential and logarithmic functions, e sub x slash sub, ln x. 2. Problem-solving strategies for Z-mains. 1. Sketch the region. Asterisk always start by sketching the curves and the region whose area you need to find. This is crucial to understanding the boundaries and identifying which function is above the other. Even a rough sketch helps immensely. 2. Find points of intersection. Asterisk determine the points where the curves intersect. These points will often be the limits of integration. Solve the equations of the curves simultaneously to find the coordinates of the intersection points. 3. Determine the upper and lower functions. Asterisk identify which function has a greater value, y coordinate, over the interval of integration. This will be the f, x, in the formula indefinite integral sub a slash sub b slash sub f, x, g, x, dx. 4. Set up the integral. Asterisk write down the definite integral representing the area. Pay attention to the limits of integration and the correct order of subtraction, upper function, lower function. 5. Evaluate the integral. Asterisk evaluate the integral using standard integration techniques. This may involve substitution, integration by parts, or trigonometric identities. 6. Check for symmetry. Asterisk look for symmetry to simplify the problem. If the region is symmetric, you can calculate the area of 1/2 and multiply by 2. 7. Consider vertical versus horizontal strips. Asterisk decide whether integrating with respect to x, vertical strips, or y, horizontal strips, is more convenient. Choose the method that leads to simpler integration. 8. Handle absolute values carefully. Asterisk if f, x, g, x, changes sign within the interval a, b, you need to split the integral into subintervals where f, x, g, x, is either positive or negative. Then, integrate and take the absolute value of each integral before adding them together. 9. Reverse approach. Asterisk in some challenging problems, you might need to consider the area of the complementary region to find the desired area. 3. Common pitfalls and mistakes. 1. Forgetting to sketch. Asterisk skipping the sketch is the most common mistake. It leads to confusion in identifying the upper and lower functions and the limits of integration. 2. Incorrectly identifying upper and lower functions. Asterisk make sure you correctly identify which function is above the other over the entire interval of integration. 3. Incorrect limits of integration. Asterisk double check that the limits of integration correspond to the correct points of intersection. 4. Ignoring the sign of the integral. Asterisk remember that the definite integral gives assigned area. You need to take the absolute value of the integral for regions below the x-axis. 5. Incorrectly handling absolute values. Asterisk when the difference between two functions changes sign within the interval, be careful to split the integral and take the absolute value of each part. 6. Choosing the wrong variable of integration. Asterisk sometimes, integrating with respect to y is much easier than integrating with respect to x, or vice versa. Choose the method that simplifies the calculation. 7. Algebraic errors. Asterisk simple algebraic errors during integration can lead to incorrect answers. Be careful with your calculations. 4. Code examples using Python and SymPy. Here are some Python code examples using the SymPy library to calculate areas under curves. SymPy is a symbolic mathematics library that allows you to define functions and perform integration analytically. Explanation of the code. Asterisk 1. Import sympy as sp. Asterisk imports the SymPy library for symbolic calculations. 2. X equals sp symbols, x, asterisk defines x as a symbolic variable. 3f equals x2 asterisk asterisk defines the function f, x, equals x caret 2. 4 sp integrate, f, x, a, b, asterisk calculates the definite integral of f with respect to x from x equals a to x equals b. The x, a, b, specifies the variable of integration and the limits. 5 sp solve, f1, f2, x, asterisk solves the equation f1, x, f2, x, equals 0 for x, finding the intersection points. 6 sp lambdify, x, f, asterisk creates a function from a sympy expression that can be evaluated numerically. This is needed because matplotlib works with numerical data, not symbolic expressions. This converts the symbolic f into a Python function that can accept numerical x values. 7 matplotlib.pyplot asterisk used for creating plots to visualize the area under the curve. plt.plot plots the curves, and plt.fill underscore between shades the area between them. Key takeaways from the code asterisk. Asterisk symbolic integration asterisk sympy provides accurate and analytical results for integration. Asterisk visualization asterisk matplotlib helps you visualize the problem and verify your solution. Asterisk intersection points asterisk finding intersection points is crucial for setting up the limits of integration. Asterisk splitting the integral asterisk when the function changes sign or the upper/lower function changes, you must split the integral into multiple parts. Asterisk horizontal integration asterisk sometimes integrating with respect to y is easier, especially when the functions are defined as x equals f, y. Fill underscore betweenx is used to shade the area when integrating with respect to y. Asterisk numpy conversion, when the symbolic values are used to create numpy arrays, example linspace, and arrays for plotting, converting them to float using float, is sometimes needed. V exampled jeemains problems and solutions. Let's look at some example problems. Problem 1 asterisk, jeemain 2021. The area, in square units, of the region enclosed by the curves y equals x sub 2 slash sub and y equals x is a. 1/6, b. 1/3, c. 2/3, d. 1/2. Solution asterisk. 1. Sketch the region asterisk sketch y equals x sub 2 slash sub, a parabola, and y equals x, a V-shaped graph. The region is bounded by these curves in the first and second quadrants. 2. Find intersection points asterisk solve x sub 2 slash sub equals x. Asterisk for x greater than or equal to 0, x sub 2 slash sub equals x sub 2 slash sub, x equals 0 equals x 1, equals 0 equals x equals 0, x equals 1. So, 0, 0, and 1, 1, are intersection points. Asterisk for x0, x sub 2 slash sub equals x sub 2 slash sub plus x equals 0 equals x plus 1, equals 0 equals x equals 0, x equals minus 1. So, minus 1, 1, is also an intersection point. 3. Symmetry asterisk the region is symmetric about the y-axis. Therefore, we can calculate the area in the first quadrant and multiply by 2. 4. Set up the integral asterisk in the first quadrant, y equals x is above y equals x sub 2 slash sub from x equals 0 to x equals 1. So, the area in the first quadrant is indefinite integral sub 0 slash sub 1 slash sub, x sub 2 slash sub, dx. 5. Evaluate the integral asterisk. Indefinite integral sub 0 slash sub 1 slash sub, x sub 2 slash sub, dx equals x sub 2 slash sub slash 2, x sub 3 slash sub slash 3 sub 0 slash sub 1 slash sub equals 1/2, 1/3, 0, equals 1/6. 6 total area asterisk the total area is 2 asterisk, 1/6, equals 1/3. Answer asterisk, B, 1/3. Python verification asterisk. Problem 2 asterisk, Gmain 2019. The area, in square units, of the region bounded by the curves y sub 2 slash sub equals 2x and y equals x is a. 4/3, b. 1, c. 2/3, d. 1/3. Solution asterisk. 1. Sketch the region asterisk sketch y sub 2 slash sub equals 2x, a parabola opening to the right, and y equals x, a straight line. 2. Find intersection points asterisk solve y sub 2 slash sub equals 2x and y equals x simultaneously. Substitute y equals x into the first equation, x sub 2 slash sub equals 2x equals x sub 2 slash sub, 2x equals 0 equals xx, 2, equals 0 equals x equals 0, x equals 2. When x equals 0, y equals 0. When x equals 2, y equals 2. So, the intersection points are 0, 0, and 2, 2. 3. Integrate with respect to y asterisk it's easier to integrate with respect to y in this case. Rewrite the equations as x equals y sub 2 slash sub slash 2 and x equals y. Then, the limits of integration are from y equals 0 to y equals 2. Also y equals, y caret 2, slash 2 within this range. 4. Set up the integral asterisk the area is given by indefinite integral sub 0 slash sub 2 slash sub, y sub 2 slash sub slash 2, dy. 5. Evaluate the integral asterisk. Indefinite integral sub 0 slash sub 2 slash sub, y sub 2 slash sub slash 2, dy equals y sub 2 slash sub slash 2, y sub 3 slash sub slash 6 sub 0 slash sub 2 slash sub equals 4/2, 8/6, 0, equals 2, 4/3 equals 2/3. Answer asterisk, C, 2/3. Python verification asterisk. Problem 3 asterisk. Find the area of the region enclosed by the curves y equals x sub 3 slash sub, y equals 8, and x equals 0. Solution asterisk. 1. Sketch the region asterisk sketch the curves y equals x sub 3 slash sub, a cubic function, y equals 8, a horizontal line, and x equals 0, the y-axis. The region is bounded by these curves in the first quadrant. 2. Find intersection points asterisk find the intersection of y equals x sub 3 slash sub and y equals 8. X sub 3 slash sub equals 8 equals x equals 2. So, the intersection point is 2, 8. Also x equals 0 is the intersection with y-axis. 3. Set up the integral asterisk we are integrating with respect to x, from x equals 0 to x equals 2. In that interval 8 equals x caret 3. Indefinite integral sub 0 slash sub 2 slash sub, 8, x sub 3 slash sub, dx. 4. Evaluate the integral asterisk indefinite integral sub 0 slash sub 2 slash sub, 8, x sub 3 slash sub, dx equals 8x, x sub 4 slash sub 4 sub 0 slash sub 2 slash sub equals 16, 16/4, 0, equals 16 to 4 equals 12. Answer, 12. 6. Practice problems. Here are some practice problems to test your understanding. 1. Find the area of the region bounded by the curves y equals x sub 2 slash sub, 4x plus 3 and y equals 0. 2. Find the area of the region enclosed by the curves y equals sin x, y equals cos x equals 0, and x equals pi/2. 3. Find the area of the region enclosed by the curves x sub 2 slash sub plus y sub 2 slash sub equals 4 and y equals x. 4. Find the area of the region bounded by y equals ln, x, y equals 0, x equals e. 5. Zemain 2023, the area of the region enclosed by the curves y equals x sub 2 slash sub and y equals square root x is. 6. Zemain 2022, find the area of the region bounded by the curves y sub 2 slash sub equals 4x and x sub 2 slash sub equals 4y. Remember to sketch the region, find the intersection points, set up the integral correctly, and evaluate it carefully. Use the Python code examples to verify your answers. By mastering these concepts and practicing regularly, you can confidently tackle area under the curve problems in the Zemains exam. Good luck! Remember, the key is practice and visualization.